A great day to one and all. I am Kim JC Ensho, and today I will be tackling or discussing combination. So think of this. What do you think is the name of this line segment? You were able to learn in your geometry that a line segment has two endpoints, and this particular segment here could be called segment AB. But the next question is this the only possibility? Is the name of this segment AB only? And the answer here is no. In fact, this line segment could also be called as line segment BA, because based on what we learned from our geometry, commutativity is one of the properties or one of the things that we could use in naming a segment. So line segment AB and line segment BA is the name of this segment. And this leads me to this question: do the arrangements make a difference in terms of quote unquote meaning? The answer here is no. In this particular case, we could see that order does not matter. So if I say AB or BA, they refer to only one line segment. And how about if I give you this another example? Supposing I have here this triangle with vertices A, B, and C. What do you think is the name of this triangle? So we could actually list all of them. We could go either clockwise or counterclockwise direction. And in this particular case, if we go clockwise and start with A, you could have triangle A, B, C. You could also have triangle B, C, A. You could also have C, A, B, which is here. Or if you go counterclockwise, you have A, C, B here. We could also have C, B, A, which is here. And lastly, B, A, C. So therefore, these are the 6 possible names of this triangle. Do these 6 names refer to 6 different triangles? And the answer is no. In fact, all of these 6 names refer only to a single triangle. And for this, based on the 2 instances I gave you, did changing the order of the distinct or different elements produce new meaning? Does order make a difference? And the answer is no. Because if you could see, as long as the elements or objects are there without regard to order, then that is still valid. So in this case, since order does not matter anymore, then it is not a permutation. And in this case, this one now involves another concept, which what we call combination. And based on the 2 instances I gave you, what do you think is the definition of combination? Speaking about combination, it is the arrangement of a finite number of objects where order is not important. The arrangement or the writing of the elements is not important as long as they are present within the set or they are present within that particular group. So in our case, 1, 2, 3 is the same as 3, 2, 1, 3, 1, 2, and so on, because again, order is not important or order does not produce new meaning. And to further understand the concept of combination, let us watch this video in Filipino. It is actually a commercial, and a little disclaimer here. I am not advocating or endorsing any product. I am using this commercial for a simple fact that this is in relation to combination. So to further understand combination, watch this. All right. And so there you have it. In the commercial I just shown to you, you were able to see that according to the commercial, how many symptoms of flu are there? There are 4 of them, namely lagnat, sipon, ubo, and body pain. So, and according to the commercial, if you have any 2 of these symptoms, it is already an indication that you have flu. And the next question I have in mind is, based on the ad, in how many ways can flu be manifested by exactly 2 symptoms? So for this particular case, how many combinations of symptoms are there that involve only exactly 2 symptoms? So we could actually list all of them because it is just manageable. So I will start from left to right. I will go lagnat, sipon, after which I'll go lagnat, ubo, then lagnat, body pain. So now I was able to list those that involve lagnat, or in English, fever. And now I will go to sipon. Shall I go sipon lagnat? No. How come not? How come I will not write sipon lagnat? Because we already have lagnat sipon. Lagnat sipon and sipon lagnat are just the same because we do not give particular premium to arrangement. Order here does not matter as long as they are present. So this time I will go to sipon now, and all throughout we will be going from left to right. So I have sipon ubo, and we also have sipon body pain. And lastly, next I'll go to ubo. Then we have ubo body pain. And I'm sure through systematic listing, I am able to list all the possible combinations. I mean, all manifestations of flu that consist of exactly 2 symptoms. So there are 6 combinations of them, and here are the 6 of them. Okay. Now, let's have our processing. If we are talking about permutations wherein order is important, and how many permutations are there if you take 2 out of 4 elements? So using our permutation formula, we have, since n is equal to 4, since we have 4 symptoms earlier based on the ad, and we will be taking 2 at a time, so our R is 2. Then by using the formula, we have 4P2 equals 4 factorial all over 4 minus 2 quantity factorial. The denominator simplifies to 2 factorial, and the numerator could be expressed as 4 times 3 times 2 factorial all over 2 factorial. I stopped with 2 factorial because I know that I could divide it with the 2 factorial in the denominator, and that's just be 1. So 4 times 3 will be 12. So therefore, 4 permutation 2 is 12. However, since the arrangement of these 2 objects, meaning the 2 manifestations, do not matter, what should we do? Based on what we discussed last time, with indistinct permutation or permutation with repeated elements, then it is necessary to divide it with a factorial of 2. Hence, by dividing by 2 factorial, we have 12 divided by 2, and we get 6. And there are 6 combinations indeed. And those 6 combinations are the ones that were provided earlier to you. So you see, in this case, using analysis, we were still able to come up with 6 combinations without actually listing all of them. And what's more important is that we could actually now derive the formula to determine the total number of combinations without listing them. Because honestly, if we will list everything, it might be very difficult or very challenging on your part, considering, most especially if the total number of elements is a big number. Hence, we could now derive the formula for such purpose. How many permutations are there if you take R out of n elements? That is, NPR equals n factorial all over n minus R quantity factorial. And note that we are actually assuming or presuming here that there's no repetition allowed, or as well as there is no element that is being repeated. And since the arrangement of these R objects that you will take do not matter, then what should we do? That is, we have to divide this expression by R factorial. And therefore, deriving the combination formula further, we could see that the number of combinations denoted by this NR, in some books it's C of NR, or in some books NCR, of n elements taken R at a time, is simply the number of permutations NPR divided by R factorial. We divided by R factorial because, again, the arrangement of R objects that you are taking do not matter. And with such, by substitution, we have n factorial all over n minus R quantity factorial all over R factorial. And simplifying this expression gives the combination of n elements taken R at a time as simply n factorial all over n minus R quantity factorial times R factorial. For all, this inverted symbol letter, this inverted A is read as for all whole numbers n and R, and that your n is greater than or equal to R. All right. And of course, we are actually assuming here that you have at least one whole number, at least one object that's present. And your R could be 0. It could be any whole number. Now, going back to the question or to the example I presented earlier, we know that flu has 4 possible symptoms, again, basing on the ad. In how many ways can flu be manifested by exactly 2 symptoms? So we could see from here that this is in fact a combination problem with n equals 4 because there are 4 symptoms all in all, and R equals 2 because the symptoms may occur 2 at a time. In this case, we will presume that 2 of them are exactly present. So using now the combination formula, NCR equals n factorial all over n minus R factorial, R factorial, and by substitution, we have 4C2 equals 4 factorial all over 4 minus 2 factorial, 2 factorial. This 4 factorial could be expressed as 4 times 3 times 2 factorial. I stop with 2 factorial because there's a 2 factorial in the denominator here, and the other 2 factorial is 2 times 1 or simply 2. And I could divide these 2 factorials. What is left is 4 times 3 all over 2. That's 4 times 3, 12 divided by 2, which is 6. So you see, by listing By using reasoning and by using the combination formula, we were able to determine that there are indeed 6 combinations of 4 symptoms showing exactly two at a time. I mean that what I meant to say rather was to show exactly 2 symptoms of flu out of the 4 symptoms. And these are the ones that were listed earlier, namely lagnat sipon, lagnat ubo, lagnat body pain, sipon ubo, sipon body pain, and ubo body pain. I hope you got it right. Now, let us move on to the different problems that involve combination. Let's discuss some of them. Examples. Number 1, a committee of 4 will be selected from 8 students. How many committees are possible? So from here, in a committee, order is not important as long as they are within the committee. So this is a combination problem. We could see that n is 8 because that's a total number of students, and you will be taking 4 at a time. We have to remember this, that for this problem, for your expression to be valid, it's important that the total number of objects is greater than or equal to the number of objects you are taking at a time. So you could see that by substitution, this becomes 8C4 equals 8 factorial all over 8 minus 4 quantity factorial 4 factorial. And for such, it becomes this 1 in parentheses simplifies to 4 factorial. So we have 8 factorial all over the product of 4 factorial, 4 factorial. And the 8 factorial could be expressed as 8 times 7 times 6 times 5 times 4 factorial. The first 4 factorial became 4 times 3 times 2 times 1. And I simply copied the second 4 factorial because my intention is to divide these two and become 1. And if you could see, it becomes 2 times 7 times 5. And you might ask, how come? 8 divided by 4 is 2. So we have here 2. The 3 times 2 in the denominator is 6. And it could be divided here. So 6 divided by 6 is 1. And the 7 times 5 will be copied. Hence, 2 times 7 times 5, it's 70. Hence, there are 70 ways all in all to form a committee of 4 members out of 8 students. I hope you got it correctly. Take note, feel free to pause the video from time to time if you wish to solve and confirm if you have the same answer as I did. Let's have the second one. 7 distinct points are placed on a circle, and 3 points will be connected to form triangles. How many distinct triangles are possible? Again, just like earlier in the case I presented to you, forming polygons using a certain number of vertices is a combination problem because the order of writing the letters does not matter as long as they appear consecutively, either clockwise or counterclockwise. So here, our n will be 7 because there are 7 points. And since a triangle has 3 vertices or vertices, then you will be taking 3 of them at a time. So with such, you have 7C3, which is equal to 7 factorial all over the 7 minus 3 quantity factorial 3 factorial. So the 7 minus 3 factorial simplifies to 4 factorial. So we have this expression here, the 7 factorial all over 4 factorial 3 factorial. And the 7 factorial could be expressed as 7 times 6 times 5 times 4 factorial. I stopped at 4 factorial because I know that I could divide it with the 4 factorial in the denominator. The 3 factorial here is 3 times 2 times 1, or 6. And so 4 factorial will be divided. It will become 1. The 6 and the 6 will also be divided and become 1. And what is left is 7 times 5. Hence, 7C3 is equal to 35. So I'm sure that if you connect any 3 points and note all the possibilities, there will be 35 triangles all in all. If you have 36, 37, 38 or more, that simply implies that you are able to list or to duplicate some of them, or double at least some of them. Or if you have less than 35, that means you are not able to list all of them. All right? Take note as well that in as much as you can also use calculators to do combinations, but for now I am presenting this to you because if you take exams specifically for college, then you might not have a calculator to use. That's why it's also good if we know how to do this by hand. Let's go to number 3. Nasho basketball team has 12 players. In how many ways can the first 5 players be chosen if anyone can assume any position? Like anyone could be the center, anyone could be the guard, anyone could be the forward, and so on. So since there are 12 and they could assume any position, then it shows here that N is 12 and R is 5 because you will be getting 5 at a time. So applying again the combination formula, you have 12C5 is equal to 12 factorial all over 12 minus 5 quantity factorial 5 factorial. The 12 minus 5 becomes 7. So this one becomes 12 factorial all over 7 factorial 5 factorial. Now, if you could see, you have here the 7 factorial. So I will express the 12 factorial as a product of 12, 11, 10, 9, 8 until 7 factorial only because I know I can divide this. The 5 factorial becomes 5, 4, 3, 2, 1. And by dividing the 7 factorial, both numerator and denominator, because that's the, okay, we have the product of 12, 11, 10, 9, 8 divided by the product of 5, 4, 3, 2, 1. And this could serve as your exercise. And the answer here is 792. So imagine if you have 12 players and you will be choosing the star 5 or the starting 5 or the first 5, there are 792 ways for the coach to do this. Number 4. A pool of 5 contestants will be chosen from 7 SPSTE and 8 regular class learners to represent Iloilo National High School for the upcoming TOSHA contest. In how many ways can this be done if 3 contestants should come from SPSTE and the other 2 contestants be taken from the regular class? So from here, if you have 7 SPSTE and 3 of them should be taken from these 7, then this follows that the number of ways to select the 3 from SPSTE is 7 combination 3 or 7C3. Because we have 7 SPSTE and you will be getting 3 at a time. And how about if you have for regular class? Remember, you only have 5 contestants. And if 3 of them should come from the SPSTE, then it follows that 5 minus 3 equals 2. 2 should be taken from the regular class. But there are 8 regular class learners and 2 of them will be taken at a time. So that would be 8 combination 2. That is, the number of ways to select from the regular class is 8C2. So we are done with the combinations. But again, what should we do with 7C3 and 8C2. That is, remember, by the fundamental counting principle, if one independent event can occur in m ways and the other independent event can occur in n ways, then they could occur, then the number of combinations is in all is mn. Hence, we have to multiply 7C3 and 8C2. So from here, we could actually simplify them simultaneously. If you wish, you could simplify 7C3, then simplify 8C2, then multiply the result. Or you could actually simplify them simultaneously. So the 7C3 is this one, 7 factorial all over 7 minus 3 factorial, 3 factorial. The 8C2 is 8 factorial all over 8 minus 2 factorial, 2 factorial, which simplifies to 7 factorial all over 4 factorial, 3 factorial, times 8 factorial all over 6 factorial, 2 factorial. So from here, by expanding 7654 factorial all over 4 factorial, and the 3 factorial is 6, so we have here 6. For the second one, I have to stop with 6 factorial because there's a 6 factorial here. So I have 8 times 7 times 6 factorial all over 6 factorial, and 2 factorial is 2. So we have here 2. From the first one, you could see that the 6 and the 4 factorials could be divided. So what will be left in the numerator is 7 times 5. In the second one, the 6 factorial will be divided, so it will become 1. 8 divided by 2 will be 4. So you have here 4 times 7. And 7 times 5 times 4 times 7 is 980. Hence, there are 980 ways for you to choose these 5 contestants given these constraints or given these conditions. I hope you got this correctly as well. And if you did, congratulations. And let's have one more question. Mrs. Pagunsan intended to bring 7 blouses, 5 pairs of pants, and 3 pairs of sandals. However, to avoid extra payment in the plane fare due to excess baggage, she was advised to bring 4 blouses, 2 pairs of pants, and 2 pairs of sandals only. So how many options does she have in all? This happens sometimes, right? And sometimes we have to make necessary decisions. And in this particular case, how many possible decisions can Mrs. Pagunsan do? So for the first one, if we talk about the blouses, she could, out of the 7, she could bring only 4. So that's 7C4 ways to choose the number of blouses. For the pants, there are 5 of them, but she is going to choose only 2 pairs to bring with her. So the number of ways to select the pairs of pants is 5C2. And for the sandals, out of the 3 of them, you have to choose only 2 pairs. So that's 3 combination 2, which is the number of ways to select the pairs of sandals. So with such, by the fundamental counting principle, we should multiply 7C4, 5C2, and 3C2. Feel free to pause the video, try this on your own, and let's see if you got the same answer as I did. And the total number of ways in all is 7C4 times 5C2 times 3C2. So with this, we could actually arrive to this expression by substitution to the combination formula. That's 7 factorial all over 7 minus 4 factorial, 4 factorial. For 5, that's for 7C4, by the way. For 5C2, we have 5 factorial all over 5 minus 2 factorial, 2 factorial. And for the 3C2, that's 3 factorial all over 3 minus 2 factorial, 2 factorial. And this simplifies to this expression here. This is achieved by simplifying only the difference inside each parenthesis. And using the definition now or simplifying each, the first one, it's 4 factorial in the denominator, which is the highest factorial. So I have to stop with 4 factorial as well in the numerator. 765 4 factorial. The 3 factorial here is 6. Then they just copy the 4 factorial. For the second one, the highest factorial is 3. So I have to stop with 3 factorial in the numerator. So I have here 5 times 4 times 3 factorial. And this one I just copied. Then the 2 factorial here is just 2. For the last one, we have 3 times 2 factorial all over 2 factorial. And this one, for the first one here, I could divide the 6. I could divide the 4 factorials. That's why I was left with 7 times 5 here. For the second one, I could divide the 3 factorials. And what is left is 5 times 4. But I have here divided by 2. 4 divided by 2 is 2. That's why I just copied the 5 and I have here the 2. And here, dividing the 2 factorials will give us 3. So I have 7 times 5 times 5 times 2 times 3. And that's 1,050 ways for Mrs. Pagunsan to choose 4 blouses, 2 pairs of pants, and 2 pairs of sandals. Out of the 7 blouses, 5 pairs of pants, and 3 pairs of sandals she has. I hope you understand or understood the lesson for today. And if you have questions or clarifications, please feel free to comment in the chat box or feel free to reach me in my social media accounts as well. And for such, please do this. But before that, let's have a recap. What is combination? It is the arrangement of a finite number of objects where order is not important. And what is the formula to determine the number of combinations of n objects taken R at a time? That is, using these 3 notations, which are having the same meaning. We have n factorial all over n minus r factorial for all whole numbers n and r, and n is greater than or equal to r. With that, I hope you understood the lesson well, and please do this activity and please pass it 2 days from now. That is on Wednesday. With that, thank you so much. God bless everyone. Take care and a great day to one and all.